Hello, we will talk about chi-square random variable in this video. So chi-square random variable follows chi-square distribution. And if the random variable x here is the summation of n independent another variable, say 1, say 2, say n's square. So we call x follows chi-square distribution with n degrees of freedom. If say 1, say 2, say n here are independent standard normal random variables. So chi-square follows name is the summation of the square of standard normal random variables. And the standard normal random variable follows the distribution, normal distribution with zero mean and standard deviation 1. So in this figure, we have several probability density curve for chi-square random variable with different degrees of freedom. So for example, this is degrees of freedom is 0.5, and this is degrees of freedom is 2, and this is 3, and this is 4, this is 5. So you can see when the degrees of freedom for the chi-square distribution increase, then the probability density curve will be as close to a standard normal distribution. And the chi-square distribution has the main property called additive. So if x1, x2 are independent chi-square random variables with n1 and n2 degrees of freedom, then the summation of x1 plus x2 also follows chi-square distribution, and its degrees of freedom is the summation of x1's x2's degrees of freedom. So the summation of x1, x2 is a chi-square random variable with n1 plus n2 degrees of freedom. And when we use chi-square random variable, usually similar as with other random variable, we will calculate between quantile and p-value. So the p-value is the probability, and quantile is another name for chi-square random variable's value, or we call this quantile or critical value. So in this figure, we call this value is quantile value, or we just write chi-square alpha n. So alpha here means the p-value, means the right side's area under this probability density curve from this critical value. So on the right side, we usually use alpha in hypothesis testing. And when we calculate the value, usually we call this p-value. Actually, these two both are the probability on the right side of a quantile value in chi-square. And alternatively, we can also calculate the quantile value if we know this p-value. So from this alpha value, we can also calculate the quantile value for this chi-square random variable. So next we show several examples, and we use R for calculation. So first, in R we use 2, actually it's 4, but here we just use 2 functions. So one called q chi-square and one called p chi-square. Actually, p chi-square is just to calculate the probability on the left side of a quantile value. So if we look at this figure again, so P chi-square will calculate this white area, and Q chi-square will calculate this quantile value. But the input is also this white area. So, for example, if we will, in example 1, determine the probability of chi-square 26 less than 30. So, we will calculate this probability for chi-square random variable with 26 degrees of freedom, and we will calculate the probability of this quantile value less than 30. So this means this quantile value is 30, and we will calculate probability of this white area, which means this is the cumulative probability of all the values in this quantile distribution, in this chi-square distribution, with the value less than this value is 30. So here this value is 30, and we want to calculate the white area. So we just use the solution. This is the solution in R, not for the larger simple. This is for the property in R programming. So we just use P chi-square 30 26. So the first is the critical value or the quantile value. Second is 26 degrees of freedom. This means the P value, cumulative probability for the chi-square. So we get this probability is 73%. So here, this white area is about 0.73. So which means about 73% of all random values in this distribution less than 30. And alternatively, we can calculate the critical or quantile value from known probability. So here 0.05 is the alpha value. So if we want to calculate the quantile value for the alpha 0.05 in a chi-square random variable with 15 degrees of freedom, then we will use Q chi-square. But here the input is 1 minus alpha, because in the chi-square expression, this value is on the right side of a critical value. But the input for the Q chi-square in R, this is the left side of this critical value. So which means we will input 1 minus alpha here, 0.05 and 15. So we will get this critical value is 25 about. So which means in a chi-square distribution with 15 degrees of freedom, this critical value is about 25, and this dashed area on the right side of this critical value is about 0.05. And example 3, suppose that we are attempting to locate a target in 3-dimensional space, and that the 3 coordinate areas in meters of the point chosen are independent normal random variables with 0, mean, and standard deviation 2. So the question is to find the probability that the distance between the point chosen and the target exceeds 3 meters. So here is 3-dimensional, and we know that the distance between the 2 points is the square of their 3 coordinates, right? Summation. So here we express the distance, or the area of the distance is d. Then the d square is x1 square plus x2 square x3 square. So here xi is the area in i's dimension, right? So this is what D is what we are interested in, and because x1, x2, x3 follows a normal distribution with zero mean and standard deviation too. And from the definition of chi-square random variable, we know is the summation of a standard normal distribution's square summation. So here we transform, say I is the xi divided by 2. Because xi minus 0 divided by its standard deviation, so we'll transform to another normal random variable. Here is the standard normal random variable. So the distance of D larger than 3 is same as the distance square larger than 9. So we calculate the probability of D square larger than 9, which is same as these three random variable summation, squares summation larger than 4 of 9 divided by 4, right? Because if we use D square here, x1, x3 here, is same as these 3 because we divided by 4 on both sides, right? So from this expression, actually this is a chi-square random variable with 3 degrees of freedom. So same to say, we want to calculate a chi-square random variable with 3 degrees of freedom, critical value larger than 9 divided by 4. So we can use R because this is we want to calculate on the right side of this critical value. So we can use P chi-square of this critical value, then use 1 minus, right? Because this will get the area on the left side and probability density curve. So what we want is 1 minus this one, so which means on the right side of this critical value. So actually the probability is about 0.52. Thanks for watching.